Hello and welcome to the 5.5 notes. And this is a section about the triangle inequality. And what I want to do is talk about how the sides of a triangle are related and the certain types of sides that we can have. So let's go ahead and zoom in here real quick on this section. And so what I want to do here is first write a statement about the sides. So what I want to say is that the sum of any two sides of a triangle must be larger than the third. Okay, than the third side. Okay, so here's what I could say. If I wanted to say, like, the first one, say PQ, okay, the sum of PQ, all right, plus the sum of QR must be larger, strictly larger than the length of PR, okay, PR. All right, and similar, and that's probably the one that you'll check the most, where you check the two small sides to see if they're larger than the largest side, okay? Because the other way around, it's pretty self-explanatory. But what I would want to say is something like this. Let's say that PQ, all right, plus PR, okay, if I took these two sides and added them together, then they have to be larger than this third side, QR. So they'd have to be larger than the third side, QR. Okay? And then similarly, if I took segment QR and added that to segment PR, okay, then that would strictly be greater than segment PQ. Okay? And so that's what we know. All right, so let's go ahead and take a look at what we could do here for something like this. And it's asking is it possible to form a right triangle with the given side lengths? If not, explain why not. So what I want to do, the trick for this is to find your two smallest sides and add them together and see if they're larger than the third. So I'm going to take 2 and 3 and just verify that this is correct. So I'm going to take, if I take 2 plus 3, is that larger than 4? Okay, and it sure is. Okay, if I take 2 plus 3, it's going to give me 5, and that is larger than 4, and this is a true statement. Okay, so since that's true, then this is possible. So yes, possible. All right. Okay, so let's go ahead and take a look at the next one. All right, again, I'm going to take my two smallest sides, which is 5 and 7, and if I add them together, will they be larger than 9? Okay, and so let's take this. Let's do 5 plus 7. Is that larger than 9? So if I take 5 plus 7, I get 12. And is that greater than 9? Is that a true statement? And the answer is yes, this is a true statement. So then yes, okay, this is possible. Okay, but we have to show this verification here, all right? Okay, let's take a look at number 3. Now, this one has side lengths of 13, 13, and 26. Now, let's see if I add these two together, if they're going to be larger than 26. So if I take 13 plus 13, are we strictly greater than 26? Okay, and the answer is no. Okay, 26 is not greater than 26. Okay, 26 is equivalent to 26. These are equal. I'm trying to show that this number is larger than this. But since they're the same, this is a false statement. Okay, and the reason why is that 13 plus 13 is equal to 26. Okay, and so this would not be, so no. Okay, no, cannot happen. Okay, all right, let's take a look at number 4. And let's do the same thing for that. Let's take our two smaller sides and add them together and see if it's larger than the third side. So I would do 9 plus 10. Is that larger than 20? Okay, 9 plus 10 gives me 19. Is that larger than 20? And that's a false statement. Okay, 19 is smaller than 20. Okay, so we would say no, Can't happen. Can't have a triangle. And the reason is because 19 is less than 20, okay? So this is kind of your verification and kind of your reasons why, okay? But I still want an answer of yes or no. No. Okay, so let's take a look at numbers 5 and 6, and this one's kind of tricky, okay? And it says, find the range for the measure of the third side of a triangle given the measures of the two sides, okay? And so here's what we want to do, okay? The first thing I want to do here is I have lengths of 5 and 9, and we need to figure out what would be the length of a possible third side, okay, that would give us a triangle. So here's what I want. Okay, I'm going to have x equal the length of the third side. Length of third side. Okay, and I'm going to set up what's called a compound inequality here. And so I'm going to do this. I'm going to label the short end. Okay, the shortest end. Okay, I'm going to put x, and then I'm going to put the longest end. Longest side. I don't know why I said end. Let me rewrite that as shortest side. Okay, and the longest side. All right. So x has to be between these two sides. Okay. So here's what I'm going to do. To get the shortest side, I would then take 9 minus 5. Okay, I'm going to take that quantity, and I know that that has to be strictly less than x. Okay, and then I'm going to take the longest possible side, which would be 9 plus 5. Okay, so I'm finding the difference between the smallest and the largest, and I'm finding the sum between these two sides. And so if I took 9 minus 5, that would give me a length of 4, which would be less than x. And then I would take 9 plus 5, which would give me 14. Okay, and so I know that my value for x, my possible third side, would have to be between 4 and 14, okay? It couldn't be 4, because if it was 4, then I'd have 4 plus 5, which equals 9, and that wouldn't work. Okay, and if it was 14, then I would do 5 plus 9, which would give me 14. So it has to be less than that. It has to be in between these two values. So I got to find the shortest possible side by subtracting, and the longest possible side by adding, okay? Let's go ahead and apply that to number 6, okay? I'm going to do the same thing. I'm going to say the shortest side, okay? I'm going to put x in the middle, and I'm going to put longest side, okay? Longest side. So the shortest side, and I know that x has to be between these two, okay? So what I would want to do is I want to take 14 minus 7, set that less than x, and then set x less than 14 plus 7, okay? And so what I get here is I would get 14 minus 7, which is 7. X has to be larger than 7, okay? But at the same time, x has to also be smaller than 21, okay? And this is my answer, and this is what we're looking for, okay? So not too terrible, but there are some procedures to this and are some methods to this, and I'm just trying to show you guys the easiest possible way to go through this. Okay, let's take a look at this proof here, and let's say that all of these, or let's just take a look at this and read through this. So you're given that triangle. And this should be ABC. Let me rewrite that. Let me zoom in here and rewrite this as triangle ABC. Okay, you're given triangle ABC, and you're given triangle CDE. And you want to show that the length of AB plus the length of AC plus the length of CD plus the length of AE the sum of all of these has to be greater than the length of AE, okay? So let's do this. Let's kind of write out a 2-column proof here. And I'm going to come over here, and I'm going to write my t-chart with my statements and reasons. Let me redraw that so it looks nice and pretty. So let me draw my t-chart. And I've got statements and reasons. Okay, and so the first thing I want to write is my given statement. Okay, and so I'm given triangle ABC and triangle CDE. Okay, and that's given, and there's not much to conclude from that, but we're just trying to show that certain lengths of those triangles are going to be larger than the others. So what I know here on step 2, okay, given triangle ABC, okay, I know that AC, I can just tell by the picture that AC is my largest side, okay? So I know this. I can set up this inequality that says that AB, segment AB plus segment BC must be larger than segment AC, okay? And that's just your triangle inequality, okay? Triangle inequality, okay? Then I also know, for the same reason, that segment CD, if I take CD and add it to segment DE, then that is going to be strictly larger than segment CE, okay? And again, the reason for that is the triangle inequality. So triangle inequality. Okay, now is the tricky part of putting it all together. So here's what I want to do. I just want to add all of these things together, okay? And so what I'm going to do here on this fourth step is I'm going to add these two pieces together with this, okay? And I'm going to say that AB plus BC, okay, those segments, and I'm going to add CD to that, so add CD plus DE, okay, then that has to be greater than segment AC plus segment CE, okay, if I add those together. And all I'm doing there is just adding two things together. So that's the addition property of equality, okay. Okay, and so then what I can do is I can just combine my like terms and simplify this and say that if I take segment AB plus segment BC, add segment CD and DE, then it's the same thing as the length from AC to CE, okay, and that's just going to be the length AE, okay, and that I figured out by the segment addition postulate. Okay, adding two segments together. So segment addition postulate. Okay, so kind of tricky, but not too terrible. But I hopefully, the proofs are one thing, guys, but I hopefully that you're able to work through these types of problems. So go ahead and get started on those notes. I had a wonderful time teaching this to you today. Please make sure that you're starting your homework. You guys are doing a wonderful job. Thank you.